Congratulations, you have made it to the final section of Chapter 3, 3-10, Perpendiculars and Distance. I know this has been a very labor-intensive unit. A lot of thinking had to go into this, very logical, all that. This section is not that. This section is labor-intensive in the work that you have to do. So, what we're doing today is trying to figure out what is the shortest distance from a single line to another point that is not on that line. Right. Again, I'm walking from my house to the store. My buddy is walking from his house, going to the same store. We want to meet up to go to the store together because we just like shopping together. We're going homecoming shopping. You guys don't do homecoming. This is 8th grade, but whatever. So what we're trying to find is the shortest distance from our line to some point that's not a line. That goes into the learning intention. I am learning how to use perpendicular lines to find the distance from a point on a line and how to apply geometric reasoning and equations to solve problems involving distance. So our goals for the day are I can explain the concept of perpendicular lines and how they relate to distance in geometry, and I can calculate the distance between a point and a line using the formula for the shortest distance. Notice how it says distance and formula in there. Guess what we're going to have to use at some point today? The distance formula. Hopefully you remember it. If not, I'll tell you. That's the big one for today. That top one, I can explain the concept. If you get this, you get it. That's all we're at. That's what that top one says. You understand what it means. The second one is being able to apply it. Application and understanding are two completely different things. So, let's take a look at this top little concept right here, distance between a point and a line. I want you to read that I'm going to give you a couple seconds to read it, or just pause the video for a second. If I start talking again and you're not done reading, go through that, because that's going to be a big part of that top success criteria that we talked about, that understanding of the concept. So go ahead and pause the video for a second, and if I start talking again before you're ready, just pause the video again. So the distance between a line and a point not on the line is the length of the segment perpendicular. So we're going to use those slopes that we were working on. And that's where this comes into play. So you were given line AB and point C. They want to know what the shortest distance is between AB and C. So line AB and point C. And that's going to be this line CD, which is perpendicular to it. So, how are we going to figure this out? Well, first thing, we need to know the slope of AB. So, figure out this line. Find line AB. So, however that needs to be done. Second step, find line CD. And find the equations for both of those. Then what we're going to do is we are going to solve a systems of equations to figure out where point D is. All right? Solve system of equations. Because we know where point C is, but we don't know where point D is, so we can't find that distance until we know where point D is. And then step 4 is the distance formula. And that's what this entire page below is that is those 4 steps broken down. I told you this was a labor-intensive one, so there's a lot of work to this. I know. These are not 30-second problems. These are longer problems. That's why I think there's 3 of them on this entire notes page, and it's 2 pages long. So it takes some space. Okay? Let's get to it. Let's try this first example. Line L contains 1.2 and 5.4. Find the distance between line L and point P. So, first step, find the equation of line L. So, begin by finding the slope through these points. They kind of already did that for you. 4 minus 2 is 2. 5 minus 1 is 4, or 1/2. Write the equation of slope using points 1, 2. They just use slope-intercept form, which is perfectly fine. You don't have to use point slope every time. They use slope-intercept. They're still plugging in x and y. We knew m. We're solving for b. So our x coordinate was 1. So, all we have here is, if we simplify this, 2 is equal to 1/2 plus b. You got to subtract 1/2, so that's going to give you 3/2. So your equation is y equals, our slope is 1/2, we already knew that, x. When we're writing an equation in slope-intercept form, we don't fill in anything for x and y. That's only if we need to find b, and we found b to be 3/2. All right. Now we need to find the equation of the line perpendicular to it. We're still using slope-intercept form. Okay? Still using slope-intercept form. We know the point. They gave us the point up here. So y is 7. M is going to be perpendicular to this. So what is our slope that is perpendicular to 1/2? Well, that would be, perpendicular is -2. So we're going to plug in a -2 here. What is my x coordinate for point P? 1. So let's fill this in. We didn't do anything with the 7. 7 stays. -2 times 1 is -2. In order to solve this, we have to add 2, which is how they got 9. So, I guess we could have filled this in over here. That's fine, whatever. -2, 1, 7, add 2. All right, wonderful for us. We can do that. This is stuff that you guys have been doing for years. And if you don't remember that, that's fine. Make sure we have it written down. All right. The equation of the line, y equals, what was our slope? -2x plus 9. Our y-intercept was 9. Now we need to solve the systems of equations. If you guys remember doing this in algebra, we're going to use elimination. We could have used something different, but the way they have it set up is that we're going to use elimination. Right? So what we're going to do, we're going to make this equation look similar so that we can get rid of the x. So I'm going to multiply this by 4, and that's what's down here. So 4y is equal to, well, 4 times 1/2 is 2x plus 3 times 4 is 12, divided by 2 is 6. So my two equations for my system is 4y is equal to 2x plus 6. My second one, I just brought this one down because these are opposites. All right? So we're going to add them. 4y plus y is 5y. These cancel. 2x minus 2x cancel. 6 plus 9 is 15, which gives me a y of 3. We're going to plug 3 in to our original equation for this line for y, because we just said y equals 3. So 3 equals -2x plus 9. We subtract 9 from each side, get -6 is equal to -2, and x equals 3. So our point that is along, if we come back up here, our point that is along this line, that is the closest to point P, is 3, 3. So if we come back up here, we're going to go over to 3, 3. So our job right now is to find the distance from P to Q. All this was just to get there. We are still at the beginning stages of our problem. Now we actually get to the work. I know there's no room down here. This is where you should be looking on doing some work on the left-hand side. I don't have a left-hand side, so I'm going to do step 4 up here. You should not do what I'm doing right now and doing step 4. You should be doing step 4 on the left-hand side, because that, again, is the end of this. This is the important part. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. You thought this was over. You're never going to have to use that again after we did it early in the year with the circles. Not true. You're going to use this a lot. So we got to know what our 2 points are. P and Q. Well, P is 1, 7. Q is 3, 3. Doesn't matter which one you use for x1, y1, x2, y2, but it just makes sense that P is x1, y1, and that Q is x2, y2. Plug that into the distance formula. You got square root x2, so 3 minus x1, 1 squared, plus y2, 3 minus 7 squared. 3 minus 1 is 2 squared, plus 3 minus 7 is negative 4 squared. You've got 4 plus 16, so square root of 20. Which, if you plug that into a calculator, because they're looking for an actual answer, you can say is about 4.5. Or if they said leave it in terms of the radical, we got to break this down into 4 times 5. Square root of 4 is 2. Can't find the square root of 5. So either of these are going to be acceptable answers. Find the equation of the original line. Find the equation of the line that is perpendicular. Solve the system of equations using those 2 equations, and then use the distance formula. A lot of steps, but we can get it done. We're going to try one more that is not quite as given to us. They don't fill in everything for us. So we've got some work to do on this second problem. I'm going to take you through this one. You're going to be responsible for the one down at the bottom. All right? So we're going to go through these same steps to solve this. Find the distance between point P and line L. Line L contains points negative 8, 1 and 3, 1. Point P has coordinates negative 2, 4. So first thing I need to do, if you want to use point slope, use point slope. You want to use slope intercept, use slope intercept. We're going to find the equation between these 2 points. Then we're going to find the equation of the line perpendicular with these 2 points, or this 1 point. Solve the system of equations, use distance formula. So, if you need to use that left side for this, use the left side for it, please. So, let's find the slope first. So, m equals y2 minus y1 over x2 minus x1, x1, y1, x2, y2, 1 minus 1 over, well, that's interesting, 3 minus negative 8 equals 0 over 11. So what is my slope? My slope is 0.
And that makes sense because my y's are the same. So that tells me I don't even have to go any farther with creating this line. I immediately know that my equation is simply y equals 1. Both of them have the same y, different x's. So this is my equation for that first line. Okay, that's my equation. What is going to be the equation of the line perpendicular to it? Well, this one's y equals. The line perpendicular to it should be x equals. And what is my x equal? -2. All right. So these are my two lines. Now, I need to solve a system of equations with these 2 points. Right. So let's get to work. Our two lines are y equals 1 and x equals -2. How can I possibly do that? Is there a y to plug in or an x to plug into? Or is there something we can cancel? No, that's... How are we going to do that? I don't know. What do you guys think? Any ideas? I'm asking you guys questions like you can actually answer me. This one can be a little bit tricky. It's hard to eliminate or substitute here simply because it doesn't really work out all that well. All right? So what we're going to think about here, a little different. We can't solve the systems of equation by substitution or elimination. What is the other way to solve a systems of equation? By graphing. Our lines are y equals 1. So I have y equals 1. I'm also going to have a line x equals -2. My point is -2, 4. So I know that's 1, 2, 3, 4. Well, the closest point is going to be here. And where's that point at? If this is -2, 4, this one's at -2, 1. We can do that because it's horizontal and vertical. If this was a diagonal, we wouldn't be able to do it this way. We'd be doing it the way we did on the front side. So how far away are these points? Well, that's the same, -2, -2. We can use the distance formula if you really wanted to, but these are the same. How far away is 4 to 1? 3. We have to be able to use all of the things that we've learned in algebra for geometry. Most of what we do this year is just going to be applying the concepts that you learned last year. Okay? Tricked you on that one. Almost tricked myself. All right, how about this last problem? Okay? I want you to pause it, see if you can't figure out this amusement park problem. All right? Pause the video, come back, and we'll talk about it. Welcome back. I know you just had so much fun with that problem. Almost as much fun as I did. So as you're going through this, if we go through our steps, first thing you have to do is you have to find the equation of the original line. So in this case, it was Main Street.
So you had to find the slope, which was -1, plug that in using one of the points. Again, whether you kept it in slope-intercept form, use point slope, really doesn't matter to me. I kind of prefer point slope simply because you don't have to do this extra step of plugging B back in. But if you forget what point slope is, you can always use slope-intercept. So you end up with the equation y equals -1x plus 2. You don't have to have the 1 there, but for the sake of simplicity, I just kept it there. Second thing is you had to find the equation of the line from our new point to somewhere along our original line. So using the slope that is perpendicular, well, our original slope was -1, so the opposite reciprocal is just 1. Plug that in using our new point. We end up with the line y equals 1x minus 4. Again, you don't need that, but for simplicity's sake, I left it in. Once you have both equations, and again, if you didn't get these, check the work, see where you differed, and see if you can figure out your mistake. Once you have these two equations, you can solve a system of equations. Because we actually had full equations, not y equals and x equals, we were able to do elimination, which is why I left the ones there so I could easily see that those were going to eliminate. I didn't know that originally, but it just worked out that way. All right, so I was able to eliminate those. We add these together, so y plus y is 2y. 2 plus negative, so just subtracting, -2. Divide by 2 to get y by itself. We got y equals -1. You plug that into either equation. They say to plug it into this one, but if you plug into the original, you will still get the same answer, so it doesn't matter. Plug y is -1 in. Subtract 2, divide by -1, you get x equals 3. So you have your new points of 3, -1. For along this line, you have your original point of -6, -10 for the entrance of the roller coaster. You plug those two into the distance formula, you end up with square root 162, which is about 12.7, and that is allowed because that is greater than 10. Wow, that was a lot of work for one problem. But the higher you get into math, the longer the problems get. And good job today. This was the end of the chapter. Coming up next is your review and test. So make sure you have all the notes done for 3-6 to 3-10. If you missed a day, forgot something, just didn't feel like doing the work one day, you got to go back and get this stuff done because we're going into that review, going into the test next. So let's finish this proofs chapter off. Let's finish this stuff so that we can get into maybe something a little more fun next. I don't know. Might be fun for some of you. Some of you might not like it, but hey, it's got to be better than proofs. Guys, good job. Good job this chapter. If you have questions, send them to me.